Hi everyone, welcome to today's tutorial. Last week we discussed very important algebraic properties known as the commutative properties, the associative properties, and the distributive properties, right? As you can see on my screen, we're going to be having a quick recap. Commutative properties of addition means that x plus y is equal to y plus x. Same applies to multiplication. Associative property means that you could regroup and still get the same outcome. As you can see on the screen, we're saying that x plus y plus z is equal to x plus y plus z. So in the first case, we're grouping x and y together. And in the second case, across the equal to sign, we're grouping y and z together. For associative property of multiplication, it's very similar. In this case, we're grouping A and B together. And at the other side of the equal to sign, we're saying B and C is being grouped together. They are the same. For distributive property, A into x plus y is the exact same as A into x. What we did here is to distribute A over x, right? And then again, we distribute A over y. And for the distributive property, it could also apply if between x and y we have a negative, right? So we distribute A on x minus, again, distribute A on y. So we get A into x minus A into y. So now let's take some examples. For the commutative property, we're saying that apply the commutative property to rewrite these equations and then evaluate both to prove the property. So the original expression and the rewritten expression. We're saying here 43 plus 21. If we change the order, it will become 21 plus 43. So let's attempt to add both the way we would normally when we're doing addition. So 3 plus 4, 3 plus 1 would be 4, 4 plus 2 would be 6. So in this case, it is 64. Let's do the same on the other side. 21 plus 43. That would be 464. So as you can see, 64 is the result here and same 64 is the result here. So irrespective of the order, we're saying that the commutative property applies to addition. Let's also look at number 2. Now we're talking about multiplication, right? Excuse me. Twelve times 31. And that is 12 times 31. Let's take some time to multiply these together. We're saying 1 times 2 is 2, 1 times 1 is 1, 3 times 2 is 6, 1 times 3 is 3. So if we add this together, we get 372. That's the result of multiplying 12 by 3. Now, let's look at the rewritten expression. In this case, it would be 31 times 12. Let's actually now multiply these together, 31 times 12, and see that we will result in the same answer. 1 times 2 would be 3, 2 times 3 would be 6, 1 times 1 would be 1, 1 times 3 is 3. So we're adding both together. Oh, 1 times 2 is 2. Sorry, I beg your pardon here. So 2, 7, 3. So in both cases, the final answer is 372, which proves the commutative property. Let's go to the next. Associative property. We're saying here that irrespective of whether we regroup or not, 10 plus 7 grouped together plus 3 would be the same as when we rewrite the expression, right? So the rewritten expression would be 10 plus 7 plus 3. And here is the original expression, original. 10 plus 7 is 17 plus 3, which is equal to 20. And here we're saying 10 plus 7 plus 3 is 10. 10 plus 10 remains 20. So whether we regroup it or not, the answer remains 20, which proves the associative property. Now let's go to associative property of multiplication. We're saying here that the original expression is 6 times 1 over 3 times 9, right? Here, grouped together. I was saying the rewritten expression here would be 6 times 1 over 3 times 9. So to solve this, we would have 6 times 1 over 3. 3 can go in 6 2 times. That is 2 times 9 here. 2 times 9, that's 18. So if we come to the other side, right, for the rewritten expression, we'll be having 6 times 1 over 3 times 9. So 3 can go in 9 3 times. So that becomes 6 times 3. 6 times 3 is 18. So again, for the associative property, we've been able to prove that if you regroup it, you still get the same outcome, which is 18 and 18 on both sides. Now, let's talk about distributive property. So the distributive property says that if we share the number outside of the bracket across both of them, right, the expression remains the same, or they have the same numerical value if you decide to resolve them, right, to the, if you decide to evaluate them, sorry. So that would be 24 plus 3. Distributive property says that we can distribute this across this and this as well. We can decide to distribute across this. So that becomes 20 times 4 plus 20 times 3. And for the second one, 9 into 6 minus 2. We can rewrite using the distributive property as 9 into 6, 9 into 2. If you decide to follow this to the end, by that I mean if you decide to evaluate and get a value for it. Let's start with the first one. 20 into 4 plus 3 would be the same as 27. 20 times 7, 7 which is 4 plus 3, right? 20 times 7 is 140. Let's go through the other method, right? We say 20 into 4 plus 3. Like we did before, we distribute 20 on 4 and distribute 20 on 3. So 20 times 4 is 80. 20 times 3 is 60. If you add 60 to 80, you get 140, which definitely is the same. Here 140, here 140. But the reason we're talking about the distributive property is because many times in algebra, you would be required to work with letters, right? Letters are not exactly numbers that you can just simplify to this point. You need to be able to understand how to use that property to be able to solve complicated algebraic expressions, right? We can do the same for 2. The original expression, right, is 9 6 minus 3. 9 into 6 minus 2, sorry. So 9 into 6 minus 2 becomes 9 times 4. And that is what? 36. Let's go through the distributive property approach. 9 into 6 minus 9 into 2. So 9 times 6 is 54 minus 9 times 2 is 18. So 54 minus 18 definitely is 36. Now I have a take-home assignment for you guys. It says identify the two algebraic properties that justify equating the expression. If you have not listened to or reviewed the last topic that we did where we extensively talked about these algebraic properties, you will need to do that to be able to solve this problem. So take a look at it here and go through it if it's required, or if you feel like you need to go through it a second time. And I believe there's something there for you to learn. And then come back to this tutorial and then come back to this take home assignment to come and solve it by yourself. Trust me, it's very simple. You just need to take a little time to understand what we'll be explaining in that last tutorial, and then you will be able to destroy this, right? So yeah, destroy. I really mean that. So thank you for joining us today. It's a wrap for today. I hope you got some value for your time. We are committed to uploading a new tutorial video every week before Sunday, 10 p.m. Eastern Time. Please share with your friends to help them as well. Subscribe to the channel, like the videos. Don't forget to turn on your notification bell so you'll be the first to know when we publish a new content. Take care and goodbye. I should also say quickly that the answer you will find in the description section. Thank you. Bye bye.